Hello everyone, I am Navya and I am going to talk about crystal defects and few topics related to it. First of all, what is a crystal? A crystal is a solid material whose constituents are arranged in a highly ordered microscopic structure forming in a crystal lattice that extends in all directions. Examples of large crystal include snowflakes, diamond, and table salt. Crystal defects. Crystals are rarely perfect. They contain large number of defects or imperfections which influence the behavior of the material. Because of these defects, the actual strength of the metal is less than the theoretical strength. Crystal defects are classified into four types: point defect, line defect, surface defect, and volume defect. Coming to the point defect, the irregularities or the deviation of atoms from their ideal arrangement in a crystalline structure. These point defects are erased due to plastic deformations. Types are vacancy, interstitial impurity, interstitial impurity. Coming to vacancies, vacancy is nothing but missing of atom from its original structure, which arises due to the thermal shocks during crystallization or plastic or mechanical deformation. As shown in the figure, we observe that difference between perfect crystals and vacancy crystals. Interstitial point defect. Extra atoms positioned between atomic sites. This interstitial point defect arises due to the plastic deformation. In interstitial point defect, the atom will be of same kind or different kind and occupies between the regular atomic structure. Interstitial impurity. When an impurity atom is small in the size, spaced between the atomic structure. Substitutional impurity. Substitutional defect is nothing but when an impurity atom replaces or substitutes parent atom. Example, brass, zinc is a substitution atom in a copper structure. Frankel defect. Frankel defect is nothing but iron is displaced from a regular structure to an interstitial site as the interstitial space is small, which is shown in the figure. Schottky defect is nothing but a pair of positive and negative ion is missing from original structure so that neutral charge is maintained in the crystal. Coming to the line defect, it is a defect arising out of a line of a row of atoms from its designated auto arrangement. This line defect arises due to the thermal stresses during plastic deformation. The line defects are shown in the below figure. Positive edge dislocation. If the vertical plane starts from the top of the crystal and never reaches to the bottom. Negative edge dislocation, which is opposite to the positive edge dislocation. That is, if the vertical line starts from the bottom of the crystal and never reaches to the top. Coming to the point of screw dislocation, atoms are displaced in two separate planes perpendicular to each other. A screw dislocation marks the boundary between the slipped and unslipped parts of the crystal. The defect can be imagined by cutting the crystal structure partly by a knife and sharing of a part of crystal along a plane parallel to cut. The screw dislocation is shown in the figure. The arrow which is in clockwise direction indicates that upper portion of the crystal shifted towards right with respect to the lower portion, and the arrow which is in anti-clockwise direction indicates that upper portion of the crystal shifted towards left with respect to the lower portion. Surface defects and plane defects. Surface defects are associated with boundaries that are separate regions of a materials and have different crystal structures. These surface defects are two-dimensional defects due to the change in orientation of atomic planes and stacking sequences of atomic planes. These caused during solidification or mechanical or thermal heat treatment of material. Stacking fault. Surface imperfections caused by stacking of one atomic. The figures A, B, C, D represents the stacking faults. Coming to the point of volume defect. Volume defects are associated with three-dimensional atomic structure. Defect occurs during solidification of material, presence of foreign particles. Plastic deformation. When a material is deformed beyond the elastic limit, plastic or permanent deformation occurs, where the material does not regain its original shape and size. The ability of a material to undergo permanent deformation is very important in all engineering applications. Coming to the stress-strain curve overview. This stress-strain curve consists limit of proportionality, elastic limit, yield point, ultimate stress, fracture. Plastic deformation occurs by slipping, twinning, or by both. Slip or a line defect. Slip or a plastic shear is a deformation mechanism in which one part of the crystal moves or slips over another part along certain planes at same distance or direction called as slip planes. The atoms move through interatomic distance relative to their original position. The plane at which slip takes place is called as slip plane and the direction at which it occurs is called slip direction. The combination of slip plane and the slip direction is called slip system. Single crystal structure slip is shown in the figure. A series of slip planes sliding on one another appears like a bar, whereas which is shown in the stage 1, stage 2, stage 3 and stage 4. Twinning or plane defects. Atoms will move at different distance and in different directions on different planes. The figure shows after twinning and before twinning. The plane across the two parts of the crystal from a mirror image called as twinning plane. The causes for twinning. The twinning occurs by plastic deformation, hot or cold working, called as mechanical twins, thermal treatment or heat treatment called as annealed twins, twinning by shock loads or called as Neumann twins or Neumann bar. Twinning plane is shown in the following figure. The difference between slip and twin. Slip is associated with line defect, whereas twinning is associated with plane defect. The stress required is less in slip. The stress required is more in the slip. Slipped portion of crystal has same orientation as of original structure, whereas twinning is mirror image. Slip line can be made to disappear by polishing the surface. Twin line remains on the surface after polishing. Occurs due to plastic deformation, due to thermal treatment and mechanical work. Atoms will move more distance, whereas in twinning, atom will move less distance. Slip occurs several seconds to form. It occurs microseconds. Appears as thin lines when viewed under microscope. Appears as thick lines when viewed under microscope. Thank you.